This lesson deals with the voltage divider rule, parallel equivalence, and current division. You can find these notes in the ECE202 ebook in Chapter 8 starting on page 21. Let me start by stating the voltage divider rule. If we have K impedances in series, this means they share the same current, then the voltage across the jth element is the input voltage, I'll call V sub S, times Z sub J over the sum of Z1, Z2 through Z sub K. Now, since we use Kirchhoff's voltage law, current law, and Ohm's law to prove this theorem in 201, as well as many other time domain theorems, and we've shown that Ohm's law and Kirchhoff's law is a map from the time domain to the frequency domain, then our proofs will be identical, except that we replace R by Z in the frequency domain. And so we don't need to repeat these proofs again. Let me state the property of parallel equivalence of impedances. If K impedances are connected in parallel, that means they share the same voltage, then the equivalent admittance is the sum of the K admittances. In other words, Z equivalent would be 1 over Y equivalent, and Y equivalent will be the sum of the admittances. Of course, those are the reciprocal of the impedances. The proof is the same as the argument we just gave in the voltage divider rule. Now, we had impedance as having a real and imaginary part, and so does admittance. So we'll have some equivalent admittance. It'll have a real part and an imaginary part. We call the real part conductance, so it's consistent with our time domain results, but the term B here is called susceptance. This was coined by Oliver Heaviside. Lastly, let me state the current divider rule. If I have K impedances in parallel, again, they share the same voltage, then the current through the jth element is I sub S, which is our input current, times Y sub J over the sum of Y1, Y2, Y3 through Y sub K. And again, it'd be the same argument we just gave in the voltage divider rule proof. These are some of the theorems that have mapped from the time domain to the frequency domain.